Today we're going to solve a LEETCODE challenge. This one is the Trapping Rainwater algorithm. It's hard, apparently, so I'm looking forward to getting into it and solving this one and stretching my brain today. So follow along with me here. We're going to be in Typescript, by the way. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So how do we solve this? How much water, where the width of each bar is 1, compute how much water it can trap after raining. Non-negative integers. Okay, I'm looking at this example. This is going to be an array of numbers. This one's output is 6. Okay, so example is 6. So I see 1 here, I see 2 here, I see another one here, and another one here, and another one here. So that's going to be 1, 2, 3, 4, 5? Or no. So 1, 2, 3, 4, 5. Okay, yeah, 6. If I could count correctly, yeah. So each bar has a width of 1, and that width is 1 unit. Okay, so we got that covered. In this case, it's 6. So how do we solve this using code? I'm looking at it, and I can see since this is 1, and that's a 0, and this one's a 2. This can at most trap 1. So this is going to take the minimum of a maximum. So this is basically 0, 1. 1 is a maximum, a new maximum. 0 is less than 1, so the maximum amount that could be trapped here is 1. If the number next to it is not another 0, or yeah, so since the number next to the 0 is a 2, that's a new maximum, but the minimum of the maximum is what computes the unit that will be trapped. So that continues here. There's a 2, 1, so this could be 1 unit of water that gets trapped, and this another unit of water that gets trapped, and this 1 would be another unit of water that gets trapped. So that's where the 3 comes from. And this 3, this is a new maximum, but it's the minimum maximum that determines the amount of water that gets trapped. Okay, I think I'm ready to start coding. So with that logic, I can say let left, we're going to create the pointers for the array. Number 0, number equal the end of the height array, so height.length minus 1 to get the position of the right side. And then we're going to let left maximum, because we're going to keep track of the maximum values. That'll be a number equal to, we're going to start it off at 0, and then let right max, also a number, equal, and we're going to start that I think in this case we can still start off at 0, because it really doesn't matter. The far right side doesn't matter, because water can't even get trapped over there anyway. So we'll just start it off at 0. And then we're going to keep track of the water that gets trapped as well. Equals 0. Okay. Now we're going to create a while loop. Left is less than right. We'll iterate through this array. And we're going to say, if we're going to start on the left side, if it's less than the right side. So if height left is less than height right, and if left side, if the left side is equal to left maximum or not. If it's greater than, then we'll have a new left max, but if it's not, then we'll have some water that can get trapped. So if height left is greater than or equal to left max, then we have a new left max. Max is equal to height left. Or else we have some water that can get trapped. It's going to be the difference between the left maximum and height of the left side. That makes sense. So otherwise, we'll go to the right side if the left side is bigger than the right. We're going to try to solve the edge cases too. So if, we'll say else, same thing with the left side. We'll keep track of the right max. So height greater than or equal to left max. No, that's an if statement. Yeah. If new, and that'll be right max. Right max equals height right. Else we have trapped water. And then we have to also iterate by incrementing the left side and also the right side. Then return the amount of trapped water. Let me see if that works. Seems like that will work. Oh. All right, yeah. We got it. I love it. Okay, so the logic was sound. We're trying to keep track of the minimum of the maximums because that represents the units of water that can be trapped. That's really interesting. that is so cool. Like, I'm just thinking about it. That's really cool to think about. That was a really cool algorithm. The trapping rainwater one, I enjoyed it. I hope y'all did too. And I'll see you on the next one. Peace.